Section 3, Converse of the Pythagorean Theorem. The converse of the Pythagorean theorem says that if the square of the length of the longest side of a triangle is equal to the sum of the square of the lengths of the other two sides, then the triangle is a right triangle. So basically, yesterday or in the last lesson, we knew that we had a right triangle, and so we could use the Pythagorean theorem to find the length of a missing side. Today, what we're going to have is we're going to have a triangle and we're going to know the three side lengths of the triangle. We're going to plug those into the Pythagorean theorem, and if it is a true statement that we get, then it would be a right triangle. And if it is not a true statement, then it would not be a right triangle. Remember, before we do these examples, remember that the hypotenuse is always going to be the longest side. So this first example says the triangles below appear to be right triangles. Tell whether they are right triangles. A, we have three side lengths of 10, 7, and 13.4. If you remember, the Pythagorean theorem is a squared plus b squared equals c squared. C is the hypotenuse, or the longest side. So in this case, I would have to plug in 13.4 for C. So I would have 10 squared plus 7 squared equals 13.4 squared. You can use your calculator. 10 squared is 100 plus 7 squared is 49, and then 13.4 squared is 179.56. Well, when we add 100 plus 49, that's 149. That is not equal to 179.56. So I can say that this is not a right triangle because the Pythagorean theorem did not work. For example B, if you have an example like this, and you're not quite sure if 6 square roots of 5 is larger than 12 or not, you can go ahead and plug it into your calculator and see what 6 square roots of 5 is in decimal form. But it will be the greatest, it will be the longest side in this triangle. So I can apply the Pythagorean theorem, and I can say 6 squared plus 12 squared plus 6 squared equals 6 square roots of 5 squared. That 6 square roots of 5 should be in parentheses, I'm sorry, because I have to square both the 6 and the square root of 5. Well, 12 squared is 144, plus 6 squared is 36, and then 6 square roots of 5 squared is 180. 144 plus 36 is 180, so this is a right triangle. So when you apply the Pythagorean theorem, remember that the longest side has to be plugged in for the C, or it has to be alone on one side by itself. And then if the Pythagorean theorem works, then it is a right triangle. If the Pythagorean theorem does not work, or you do not get an identity, then it is not a right triangle. The next theorem says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. And then this next theorem follows that one, and it says if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. This example says decide whether the set of numbers can represent the side lengths of a triangle. If they can, classify the triangle as right, acute, or obtuse. Remember really quickly, it was several chapters ago, but to tell if three numbers could be the side lengths of a triangle, you have to add 2 of them, and that has to be greater than the third side. So for A, they give us 18, 8, and 24. If you did 8 plus 18, that would be greater than 24. 18 plus 24 would be greater than 8. And then 8 plus 24 would be greater than 18. Because all of those, the sum of 2 of those numbers is greater than the third number, we know that these could be the side lengths of the triangle. What I'm going to do is I'm going to go ahead and I'm going to kind of apply the Pythagorean theorem, but instead of an equal sign, I'm just going to leave a box there because I need to compare these two values. I have 8 squared plus 18 squared equals 24 squared. Again, just a reminder, your longest side length needs to be on one side by itself. 8 squared is 64. 18 squared is 324. And then we have 24 squared is 576. Go ahead and add 64 plus 324, and you get 388, and then 576. When you're comparing these two numbers, we would say that 576 would be greater than the 388, or 388 is less than 576. Because the 576 was just the one side, the longest side, and it is greater than the sum of the square of the two shorter sides, we could say that this triangle would be obtuse. For part B, if you look at those numbers and add two of them together, they're going to be greater than the third number, and that's true for all three combinations that we can make. So I can go ahead and do the same thing that I just did with A. In this case, I'm going to have 3.2 squared plus 4.8 squared, and I'm comparing it to 5.1 squared. 3.2 squared is 10.24. 4.8 squared is 23.04. And then 5.1 squared is 26.01. When you go ahead and add these, you get 33.28 is compared to 26.01. In this case, the sum of the square of the two smaller sides is greater than the square of the larger side. So this triangle would be an acute triangle. This next example says you want to make sure a wall of a room is rectangular. A friend measures the four sides to be 9 feet, 9 feet, 40 feet, and 40 feet. He says the measures prove that the wall is rectangular. Is he correct? First of all, let's just go ahead and read B. B says you measure one of the diagonals to be 41 feet. Explain how this you can use this measurement to tell whether the wall is rectangular. Going back to A, do we have enough information to say that this is a rectangular wall? We do not have enough information because if you remember, the definition of a rectangle is that you have four right angles. And just telling me that the side lengths are 9, 9, 40, and 40, it does tell me that it could be a parallelogram, but it does not tell me that it has to be a right angle. So go ahead and we can say, no, it could be a parallelogram. To be a rectangle, it has to have right angles. For B, it says you measure one of the diagonals to be 41 feet. Explain how you can use this measurement to tell whether the wall is rectangular. You could go ahead and draw yourself a picture for this. Go ahead and draw a rectangle, label two of the sides 9 feet, two of the sides 40 feet. Draw on a diagonal and label that 41 feet. And what needs to happen is the Pythagorean theorem needs to be true for those three numbers in order for this to be a rectangular wall. So the diagonal would be the hypotenuse. If the Pythagorean theorem works, the wall is a rectangle. When we apply the Pythagorean theorem, we would have 40 squared plus 9 squared equals 41 squared. 40 squared is 1,600, 9 squared is 81, and then 41 squared is 1,681. So the Pythagorean theorem does work, so we can say that this would be a rectangular wall because we know that we have right angles based on the Pythagorean theorem. Today's assignment is on page 546. It's numbers 8 through 28 and 32.